Hello, welcome back once again. I am 100% sure that over 80% of calculus students are going to be scared at the first glance at this integral, right? Just imagine we have the integral of x raised to the power of 11 divided by x to the power of 8 plus 1 dx. And this is not something we can easily figure out the use substitution, okay? So what are we going to do? Now, let us think about the best approach to this integral, okay? Now, let's write this integral as, now, let us see the magic. This is 1 over 8 right over here. And then I'm going to have 8 up here. And then x to the power of 11, I'm going to split as x raised to the power of 4. It will be multiplied by x to the power of 7. You get the idea? Because if we multiply both, we add the powers, and that gives us x to the power of 11. Then divided by, here we have x raised to the power of 8 plus 1 dx. Then we do the following. This is going to be 1 over 8. The integral, so this is going to be x raised to the power of 4. Then multiply by 8x to the power of 7. Attach the dx right over here. And then divide by x raised to the power of 8. And then plus 1. Okay, so what are we going to do next? Now, let us make the following nice substitution. Okay, so we're going to make the following substitution. So we're going to let me change the color of my pen. So we're going to let x raised to the power of 8 equals t. But how do we get x to the power of 4 as we're seeing it right over here? Then we need to take the square root, right? So if you take the square root from here, so it implies that x to the power of 4 is going to be the square root of t. I think this makes sense. Now here differentiates both sides, we get 8x to the power of 7 dx, as we can see it right over here. So this one right over here is going to be equal to dt. Now, making our cool substitution, we're going to get 1 over 8. The integral, this is square root of t, divided by, this is going to be t plus 1, and then dt. Okay, are we done? No, one more your substitution, okay? So here we're going to let the square root of t equals y, square both sides, we get t is equal to y squared, differentiate both sides, we get dt is equal to 2y dy. So therefore I is going to be equal to 1 by 8. The integral, so up here we have y, then divided by, this is going to be y squared plus 1, and then multiply by 2y dy, because that is our dt. Okay, the 2 is going outside, and 2 all over 8, that is giving us 1 all over 4, right? So we have this equal to 1 by 4. The integral, up here we have y squared, then divided by y squared plus 1 dy. So you see how the magic is working out. So again, we have to perform another magic by writing this as y squared plus 1 and then minus 1, right? Then divided by y squared plus 1, and we have dy. And what is next? Splitting of denominator time. So I is going to be equal to 1 by 4. The integral of this is going to be y squared plus 1 divided by y squared plus 1 dy, right? Then minus 1 over 4. The integral of 1 divided by y squared plus 1 and then dy. So you can see we have some nice and cool cancellations going on. This is 1, right? So here I is equal to 1 over 4. The integral of 1 dy is giving us y, right? Then minus, this is going to be 1 over 4. The inverse tangent of y, and then plus c. So what is our y? Remember, square root of t is equal to y. So we replace. We get I is equal to, oh my god, what are we getting? So this is going to be square root of t by 4 minus 1 over 4 multiply the inverse tangent of square root of t and then plus c. Again, what is square root of t? Remember, square root of t is equal to x to the power of 4, and boom, we have our solution. That will give us x to the power of 4 divided by 4 minus 1 over 4, the inverse tangent of x raised to the power of 4, and then plus c. Oh my God. This is one of the most beautiful integrals I've ever met, okay? So here we can now deduce. So we can say that the integral of x raised to the power of 11 divided by x to the power of 8 plus 1 dx is equal to x to the power of 4 divided by 4 minus 1 over 4, the inverse tangent of x to the power of 4 plus c. So this is our solution. Thank you for watching. Please subscribe to support my channel.